Okay, this is my reference table review for page 6, getting us ready for our Regents and for our final. So let's get going. This is page 6. It would be helpful if you opened up your own reference tables so you weren't staring so intently at the picture that I have on the screen. It might help you see it a little bit better. Let's take it apart and see what it looks like. This is the first graph that's on there. It is the rock cycle. It shows you the three main types of rocks. It also shows you how they were formed. It shows you how they get broken down, and it also shows you how they turn into each other. And we will be going through the rock chapter and reviewing this over and over again. You'll be drawing this very same diagram. So this will be fresh in your mind and you will remember this one very easily. So I'm not going to spend too much time on this one. This one is an interesting one. This is velocity. And this is, if I had a river, and when we get into our chapter that we're doing on erosion, when I have a river and something can be carried away by the water, this shows me just how big something can be and still be moved in the water and how fast the water has to be going. So if you look down on the bottom, it's stream velocity. That's how fast the water is going. If you look on the left-hand side, it says particle diameter. That means how big the piece is. So if I have a little tiny piece of clay, how fast does a stream have to go and still be able to carry that clay? Well, what happens if I have a pebble? How fast does a stream have to go in order for the pebble to be able to be moved? How fast does it have to be to move a boulder? So all of those things are on the scale of stream velocity. That's how fast the stream is going, and it's measured in centimeters per second, and how big my particle is, and that is in centimeters. So that's the main thing of this graph. But it also shows you something else, which is not thought of by the title of the graph. It shows you how big something has to be in order to be called a boulder. How big something has to be called a pebble. For instance, if you look where it's labeled pebble, a pebble is something that has a diameter of 0.2 up to 6.4. Anything with a diameter of that size is called a pebble, and anything that is below 0.0004 is considered clay. And so you can see, not only is this graph showing you, how big a fast river can carry stuff, how little a slow river can carry it. It definitely shows you that, and that's there. But it also shows you the size of the different particles. And when we do sedimentary rocks, that makes sense to you.